In this video, I will be discussing and demonstrating what I refer to as the magic triangles. I will provide some background information regarding the importance. I will also share some helpful guidelines, and I will also be demonstrating problems using the triangles. In chemistry, it is important to be able to obtain a capability of being able to discover what you are looking for with a limited amount of information. You may not always be given all the information you want, but you will be given all the information you need to discover whatever it is that you are seeking to find. It is critical to have an understanding of each individual triangle and the calculations that can be made within them. It is equally essential to be able to properly utilize the three triangles interchangeably because one of their main functions is to serve as the foundation for how you will complete future chemistry problems such as math equations, the determination of the limiting reagent, calculating the percent yield, problems within the chemistry lab, as well as many other mathematical chemistry problems. In regards to some guidelines, you will need to be able to complete English metric conversions. You will also need to be able to calculate molar mass and also calculate or be able to convert between atoms and molecules in order to properly use the three triangles. Your atomic weight sheet that was given to you as a beneficial resource should remain handy during the completion of these problems. Notice that moles is present in all three triangles, which is what allows for the conversion between all three of them. Also, to reiterate what was stated in the first video, it is important to remain consistent with unit labels in order to avoid potential confusion and miscalculations. You also need to pay attention to the number of significant digits, and it is also important to identify what you were given and what you are looking for. Here are two of the three magic triangles I have been referring to. On this first triangle, we have grams at the top, and then below there are moles, and next to that there is molar mass, which is given in grams per mole. The second triangle has either atoms or molecules at the top, moles at the bottom, and next to that is a constant, which is 6.022 times 10 to the 23rd, which is given in atoms or molecules per mole. This constant number right here is a number that was given to the individual weight of a mole of a compound. We use these triangles using the process that the bottom two portions will be multiplied together to get you the top, or that the top will be divided by one of the bottom portions to give you the opposite portion of the triangle. In this video, I will begin by completing two problems within the first triangle, then two problems within the second triangle. Next, I will complete two problems using both the first and the second triangles interchangeably. Lastly, I will be completing two problems within the third triangle individually. The purpose of this video is to focus on the breakdown of the triangles and the calculations that can be made within them. With that said, let's begin. I am aware that you probably cannot read all of this small print handwriting right here, but that's why I included it on the PowerPoint so that you will be able to understand what problems I am going through. The first problem asks how many moles are in 6.56 times 10 to the negative third grams of sulfuric acid, which is H2SO4. It's asking us for moles, and it's giving us grams. Therefore, we know that we will be dividing in order to get moles. We start by writing our given on the top, which is 6.56 times 10 to the negative third grams. And then we will write this over 1. As I said, we will be dividing by the molar mass. Therefore, we need to calculate the molar mass of H2SO4. So we have H2SO4, which has 2 parts hydrogen. Hydrogen's atomic weight is 1.01. 1 part sulfur. Sulfur's atomic weight is 32.07. And we have oxygen with 4 parts, and its atomic weight is 16.00. Once you multiply that out, you will be given 98.09 grams per mole. and we will be writing this on the bottom. We will write 98.09 grams, and then on the top, we will write moles. Grams will cancel out grams, and then we will be left with moles, which is what the problem asked for. Once you multiply everything on the top and divide it by everything on the bottom, you will receive the answer 6.69 times 10 to the negative fifth H2SO4 moles. My final answer has 3 significant digits because my given had 3. I also have the compound and the unit labeled within my final answer. We will now move on to the second problem. We will cross that one out. The second problem states that we need to convert to grams. We are given 3.579 times 10 to the first moles of carbon dioxide, which is CO2. We are asked to convert to grams, and we are given moles. Therefore, we know that we will be multiplying our given times the molar mass to give us grams. We will begin this problem by writing the given on top, which is 3.579 times 10 to the first moles. And then we will be writing that over 1. As previously stated, we will be multiplying it by the molar mass. Therefore, we need to calculate the molar mass of CO2. In CO2, we have 1 part carbon, which is atomic weight is 12.01. And then we have 2 parts oxygen, with its atomic weight being 16.00. That combines to 44.01 grams per mole. We will be multiplying them together, so we write 44.01 grams, and then we write moles on the bottom. Moles will cancel out moles, and we will be left with grams, which is what we are asked for. Once you multiply everything on the top and divide it by everything on the bottom, you will be given 1.575 times 10 to the third CO2 grams. My answer has 4 significant digits, just like my given. I also have the unit and the compound labeled. We will now move to the third problem. The third problem asks, how many moles are in 3.99 times 10 to the negative second molecules of barium chloride, which is BaCl2? We will be using the second triangle for this, and we are given molecules. So we will write 3.99 times 10 to the negative second molecules, and we will be writing that over 1. Since we were asked for moles, we know that we will be dividing by the constant to give us our answer. Therefore, we will write 6.022 times 10 to the 23rd molecules. And then we will be writing moles on top. Molecules will cancel out molecules, and we will be left with moles, which is what we were asked for. Once you multiply everything on the top and divide it by everything on the bottom, we will be given 6.63 times 10 to the negative 26 BaCl2 moles. My final answer has 3 significant digits, just like my given, and I also have the compound and the unit labeled. We will now move to the fourth problem. The fourth problem states to convert the following to molecules. We are given 56.38 times 10 to the negative fourth moles of methane, which is CH4. We are asked to convert it to molecules, therefore we know that we will be multiplying our given moles by the constant. We will begin by writing our given on the top, which is 56.38 times 10 to the negative fourth moles. We will be writing that over 1. And since we are multiplying, we will be writing the constant on the top, which is 6.022 times 10 to the 23rd. We will be writing molecules on the top, and then moles on the bottom. The moles will cancel out the moles, and we will be left with molecules, which is what we are asked for. Once you multiply that out, you will get 3.395 times 10 to the 21st CH4 molecules. My given has 4 significant digits, which is the same, my final answer has the same number, which is 4 of significant digits, as my given. And then I also have my compound and the unit labeled. We will now move to the next problem. This next problem is slightly different as well as a little more challenging because we will be using both the first and the second triangles interchangeably rather than individually. Our problem is how many grams are in 2.243 atoms of hexane, which is C6H14. We are asked for how many grams, but we are given atoms. Therefore, we know we will be using both these triangles. Since we are given atoms, we will write that on the top. We are given 2.243 atoms, and we will be writing that over 1. In order to get moles, we will need to divide this by the constant. So on the bottom, we will be writing 6.022 times 10 to the 23rd atoms. And we will be writing moles on top. We are given moles, therefore we can now transition to this triangle. We are asked for the grams, therefore we need to multiply this by the molar mass of C6H14. Therefore, we need to calculate it. So we have C6H14, which has 6 parts carbon with 12.01 being its atomic weight. And then we have 14 parts hydrogen with 1.01 being its atomic weight. Once you calculate that, you will get 86.20 grams per mole. Since we are multiplying that to get to grams, we will be writing that on the top. So we write 86.20 grams, and then we put moles on the bottom. Atoms will cancel out atoms, moles will cancel out moles, and we will be left with grams, which is what we were asked for. Get rid of this so we have some room. Once you multiply everything on the top and divide it by everything on the bottom, you should get the answer 3.211 times 10 to the negative 22nd C6H14 grams. My final answer has 4 significant digits because my given did. I also have the compound as well as the unit in my final answer. We will now move to the next problem. problem asks, how many molecules are in 3.97 times 10 to the 5th grams of vanadium bromide, which is VBr2? We are asked for molecules, but we are given grams. Again, therefore we know we'll be utilizing both triangles to get our final answer. We will start by writing our given on the top, which is 3.97 times 10 to the 5th grams. And we will be writing that over 1. Since we are given grams and we need to find moles in order to transition to the next triangle, we will need to divide it by its molar mass. So we will go ahead and calculate that. So we have vanadium bromide, 1 part vanadium, which has a molar or atomic weight of 50.94, and we have bromide, just 2 parts, which has the atomic weight of 79.90. Once you calculate that out, you will be given 210.74 grams per mole. Since we will be dividing that, we will be writing that on the bottom. So we have 210.74, writing grams on the bottom and moles on the top. Now we are here and we can move to the second triangle. We are asked for molecules, therefore we know that we will need to multiply this by the constant. We will write the constant on the top, which is 6.022 times 10 to the 23rd. We will be writing molecules on the top and moles on the bottom. Grams will cancel out grams, moles will cancel out moles, and we will be left with molecules, which is what we want for our final answer. Once you multiply everything on the top and divide it by everything on the bottom, you will be given an answer of 1.13 times 10 to the 27th vanadium bromide molecules. My final answer has 3 significant digits because my given did, and I also have my compound and my unit labeled. That completes the work that is going to be used, or that will be done within the first 2 triangles. Here's the third triangle I have been talking about. And for this one, we have moles on the top, which is different than the first 2 you may notice. On the bottom, we have liters, and then next to that, we have this bolded M, which stands for molarity, which is given in moles per liter. I will now demonstrate 2 problems within the third triangle individually. Our problem states, sodium was added to water to speed up the boiling process during cooking. How many moles of sodium were added to the 3-liter solution of water if it had a molarity of 5.367? That's a little wordy, but in all reality, you only need to pay attention to the final 2 numbers. So since we are given liters, we are given 3 liters, so we will be writing that on top. And we are trying to find moles, so we know that we will need to multiply it by the molarity. The molarity was 5.367, and we will write moles and liters. These do not cancel out because this right here symbolizes the molarity. And then once you multiply the liters and the molarity, you will be given 1.610 times 10 to the 1st sodium moles. And then we have the same number as our given for significant digits in our final answer. And then we also have the compound and the units labeled. I will now move on to my final problem. This problem asks if there are 5.327 times 10 to the 8th moles of NaOH in a 25-liter solution, what is the molarity? We are asked what the molarity is, and then we are also given moles in liters. Therefore, we know that we will be dividing the moles by the liters to get the molarity. We are given 5.327 times 10 to the 8th moles. So we will be writing that on the top. And in order to get molarity, we know that we will be dividing by the liters, which we were given 25. And then again, we will put this bolded M because, as previously stated, although they will not exactly cancel out, once they are put together, they do equal the molarity. Once you multiply everything on the top and divide it by everything on the bottom, you receive 2.131 times 10 to the 7th NaOH molarity. My final answer has 4 significant digits. It has the compound as well as the unit labeled. That concludes all the problems that I will be doing in this video. Thank you for watching, and I hope it helped you achieve an understanding of the three magic triangles. I can guarantee that they will remain important.